So in the last section, we talked about solving by graphing, and that's where you graph your quadratic, right? And then you find where the x-intercepts are, and that's your solution. The second way to find the answer or the solutions to a quadratic equation is by factoring. So there's different types of factoring that can happen, right? There's the greatest common factor. It's where you pull something out. There's the difference of squares, and then there's a trinomial. So if we go down to example number 1, it says factor each quadratic equation to determine the roots. Remember, roots are the same as intercepts, x-intercepts, or the zeros. Okay, so I think it'll be pretty straightforward, but let's factor this first one. So we have x squared plus 2x minus 24. So we say what times what equals negative 24, and what plus what equals positive 2. And there's lots of things that multiply to 24, but I think 6 and 4 would be our best option. Yeah. So 6 times 4 equals 24, and then I think I'm going to make the 4 negative because I ultimately want a positive 2 when I add. Excellent. Okay. So then we set up our brackets. So we have x at the front of each one, and we plug in the values that we found. So 6 and negative 4. And don't forget to make it equal to 0. This part's extremely important, that we still make it equal to 0. Okay? So it must equal 0. So if we look at each bracket, we're trying to figure out what can we put in for x that will make this whole expression 0. So if we look at let's look at the second bracket first. What would make that bracket 0? What would I have to plug in here to make this bracket 0? Because remember, we're multiplying. So if we make this one 0, then the whole thing's going to be 0. If we make this one 0, then the whole thing's going to be 0. So we look and we say, okay, what would make this 0? Well, if x equals 4, then 4 minus 4 would equal 0. So that's one root of the equation, or one solution. And if we look at this one here, we would say x would equal negative 6, because negative 6 plus 6 would equal 0. So our two solutions are x equals negative 6 and x equals positive 4. And that's it. And then we always have to check, because sometimes there's extraneous roots. So if we check, we have negative 6 squared plus 2 times negative 6 minus 24. We want this to equal 0. So we have positive 36 minus 12 minus 24. And we get 0 equals 0, which is awesome. And then we check our second one. So 4 squared plus 2 times 4 minus 24 equals 0. So we get 16 plus 8 minus 24 equals 0. So 0 equals 0. Does that make sense? Excellent. Okay, so factor, check your answers, and that's about it. So let's try one that's slightly more challenging. Are we okay to go to the next page? So let's skip B, and let's go straight to C. The only comment I have to make about question B is make sure everything's on one side. So in this case, I would move the 10x and the 16 over here, so the x squared stays positive, and then move everything over. Okay, but I'll leave that to you to factor. It's pretty straightforward. Okay. All right, so let's go to C. So C is 6x squared minus 11x minus 35. Okay. Now, before you start saying what times what equals the last one and adds, make sure that you see if you can factor anything out first, like a common factor. In this case, 6, 11, and 35 have nothing in common, but if they had all had 2 in common, it would have made our lives much easier. So in this case, we have to say what times what equals 6 times negative 35, which is, let's see if I can do mental math, negative 210. what plus what equals negative 11? Now it's a pretty large number, but it's a nice number because it's 210. So for me, I can see that 21 times 10 is going to give me 210. And I want there to be negative 11, so I'm going to make the 21 negative. Okay, so now that we have our numbers, we can move on to the factoring part. Okay, so start by writing the first term again, 6x squared. Then take either term that you found, so let's take negative 21x plus 10x minus 35, and don't forget your equals 0. Make sure it equals 0, okay? It's extremely important. And remember, we do this because negative 21x plus 10x still equals negative 11. We've just written it in a different way. Okay. So then we're going to put brackets around the first two and brackets around the second two. And we ask, do 6 and 21 have anything in common? Just 3. So take out a 3 and an x, and we're left with 2x, take away 7 in the first bracket. So we're factoring out the greatest common factor in each bracket. In the second bracket, we're going to take out 5, and that's the only thing they have in common. So we're left with 2x, take away 7, equal to 0. Don't forget your equal 0, otherwise it's not an equation anymore. And last step is we gather the ones on the outside, so 3x plus 5, and they both have 2x minus 7 in common, so we multiply that up. Okay. So that's just basic factoring. And now we have to figure out what would make each of them 0. So if we take the first one and we say 3x plus 5 equals 0, we need to solve and see what would make this 0. Okay, so do a little bit of basic algebra, subtract 5 from both sides, and then divide both sides by 3. So one solution would be negative 5/3, and the other solution would be, we add 7 to both sides, divide both sides by 2, so we have 7/2 as our solution. Now we do have to check it, which is going to be a lot of fun. So let's go on the side here and check our answers. So the first one is negative 5/3 squared. 11 times 5/3 negative minus 35. I hope you're good at fractions. So we have 6 times 25 over 9 plus 55 over 3 minus 35. And you can use a calculator at this point if you'd like. I would encourage you to not use a calculator and test your fraction skills. So 6 and 9 we can cancel out 3. So we have 50/3 plus 55/3. If we multiply 35 by 3, we get 105/3. And so we can see that 0 equals 0. Does that make sense? That was some fast fraction work. Not to, praise myself. Okay, and I'll let you check the second one on your own. Okay, so check 7/2 on your own.